Hello everyone. So today we will start with the numericals based on the groups. So first numerical is saying that show that a group and a set G comma plus 8 is an abelian group for a set. So set is given as it is having the elements from 0 comma 1 comma 2 up to 7. Operator is given as uh, addition modulo 8. That means all the operations will be performed on this set are of this type a plus b mod 8. So this is the operator way of and the different elements given as 0, 1, 2, 3, 4, 5, 6, 7. Now as this is an infinite set, so we can write all possible combinations and the results of operation performed on this. So the operator defined is a plus 8. So we write operator here, we write the elements 0, 1, 2, 3, 4, 5, 6 and 7 here. Okay, so one grid is not there, so we will consider here only. And the same elements will write in the row order also. So row is 0, 1, 2, 3, 4, 5, 6 and 7 here. Okay, so these are the numbers in the columns 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. Okay, now we have done this matrix in order to find out the all possible pairs that can be formed with these elements. So let us start the operation. So 0, 0. So 0th row and 0th column. So this 0 plus 0 operation we have to perform is a plus b mod 8. So here a is 0, b is 0. So 0 plus 0 is 0. 0 mod 8 is 0. So this entry will be a 0. Then 0 plus 1 is 1. 1 mod 8 is a 1. 0 plus 2 is 2. 2 mod 8 is a 2. 0 plus 3 is 3. 3 mod 8 is a 3. 0 plus 4 is 4. 4 mod 8 is a 4. So similarly it is 5. Similarly it is 6. It is 7. 0 plus 7 is 7. 7 mod 8 is a 7. Now next row we will find. Now next row is 1. So same operations we have to perform 1 with 0, 1, 2, 3 up to 7. So 1 plus 0, 1, 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4, 5, 6, 7. Now 1 plus 7, here 1 plus 7 is 8. 1 plus 7 is 8 and 8 mod 8 is 0 here. Okay, let us solve this. A is 1 plus 7 mod 8. So 8 mod 8. Mod operation means on dividing by this number, what will be the remainder? So 8 mod 8 is result is 1, remainder is 0. So remainder we have to write. So here we are writing a remainder. Now 2 plus 0, 2, 3, 4, 5, 6, 7, 8. 8 mod 8 is 0. 9. 9 mod 8 is 1. Now here it is 3, 4, 5, 6, 7, 8. Sorry, 8 mod 8 is 0. 9 mod 8 is 1. 10 mod 2 is, 10 mod 8 is 2. So similarly, now right, you might have understood what is the pattern. So here it is 4, 5, 6, 7, 0, 1, 2, 3. Here it is 5, 6, 7, 0, 1, 2, 3, 4. Here it is 6, 7, 0, 1, 2, 3, 4 and 5. And here it is 6, 7 plus 0, 7, 0, 1, 2, 3, 4, 5, 6. Okay, now this is the result matrix that we have built by performing an addition modulo 8 operation on all possible pairs on the set. Okay, so in order to say that it is a abelian group, we have to find out whether it is a abelian group or not. So in order to say it is a abelian group or not, what we have to check, we will have to check all the properties. Which properties? Definition of abelian group we have studied as a group that satisfies the commutative property, the abelian group. So for group, we have to first check the closure property. Closure. So what closure says? Closure says that if A comma B belongs to G, then A star B should also belongs to a G. Now, if you observe the results in the matrix, so these are the all possible pairs of A comma B. We have performed this operation and we have got these as the result. Now observe these results. So there are in the results there are the elements from 0 to 7. There is no element outside this group, 0 minus a negative element or the elements which are greater than 7. So all the elements 0 to 7 are the part of the set. All the elements from 0 to 7 are the part of the set. That means we are obtaining the results by performing the operation in this closure only. So it satisfies the closure property. So what you will write here as all results are in set G operation. So it satisfies closure property. Okay, so this is satisfying the closure property. Now let us check the next property. Next property is a associative. Second is a associative. So what associative says, if A by B C belongs to a set G, then A star B star C is equals to A star bracket B star C. So this is the associative property. Okay, now let us take any numbers. A equals to, let us say, 0, B equals to, let us say, 2, C equals to, let us say, 5. Okay, so you can test for any numbers, any possible ABC, all belongs to set G. Then left hand side we will write as LHS equals to A star B bracket star C. Okay, so operator here is a element A is 0, operator is plus 8 and B is 2. B is 2 plus 8, C is 5. So if you solve this, 0 plus 2, 2 mod 8 is 2. Now 2 plus 8, 5. Meaning of that is 2 plus 5, 7. 7 mod 8 is 7. So left hand side we are getting as 7. So similarly find out the right hand side. So what is the right hand side? A star B star C. So it is equals to A is 0, star means plus 8, B means 2, star is plus 8 and C means 5. Okay, so if you solve this, you will get 0 plus 8, 5 plus 2, 7, 7 mod 8 is 7. So 0 plus 7, 7, 7 mod 8 is 7. So we are getting here left hand side is equals to right hand side. So therefore set is associative with respect to operator plus 8. Okay, now there are two properties we have checked. Now next property we have to check is the identity element. So let us check whether it is satisfying the identity property or not. So next property is the identity. So what identity property says, A star E equals to A for A comma E belongs to a set G. Okay, so what is our identity element that we have to find? So we have studied identity element for us addition and subtract. Addition is a 0 and multiplication it is 1. So let us check whether 0 is a part of set. Yes, 0 is a part of set and whether it is satisfying the property or not. So elements of set are 0. So 0 plus 8, 0 gives you 0. Then 1 plus 8, 0 gives you 1 plus 0 is 0 mod 8 is 1. Then 2 plus 8, 0 gives you 2. Then 3 plus 8, 0 gives you 3. So similarly, if you solve it for 4, 5, 6, it will give you the same. Now let us check it for 7 plus 8, 0 gives you 7. That means A. So this is A. E we are keeping as constant 0 and we are getting the result as A. So by having this, it satisfies the identity property. Set satisfies identity for E equals to 0. Set satisfies the identity property for E equals to 0. So it is a monoid. Now let us check a group property. So what is group property? Commutative. Okay, for testing a commutative property, what commutative property says? So commutative property is called as, sorry, not a commutative property. A group is a group that satisfies the which property? Inverse property is called as the commutative inverse. So what inverse says? A star A inverse equals to E. Okay, now we know E. So as we know E equals to 0 here. Now let us find out the A inverse. Okay, so we will write here A. We will try to find out A inverse. That will give you the E. A plus 8 A inverse, which is equals to E. That means it should give you the 0 compulsory. Okay, let us take A 0. Okay, now remember that identity element, sorry, inverse element for the identity. 0 is the identity element. So inverse of 0 is always a 0. Inverse of identity element is always a identity element. Now let us check 1 on performing operation modulo 8 with A inverse. That should give you the what? 0. That should give you the 0. And which is that element? That element is 7. Why 7? Because 1 plus 7 is 8. 8 mod 8 is 0. So 1 plus 8 mod 7 is equals to 0. That's why 7 is called as inverse of 1. Similarly for 2, what will be inverse? Inverse will be 6. For 3, inverse will be 5. For 4, inverse will be 4. For 5, inverse will be 3. For 6, inverse will be 2. And for 7, inverse will be 1. So on performing this operation, all the results you will get as 0. Okay, remember in inverse, what is required? In inverse, it is required that A star A inverse should give you the identity element. Identity element we have found as 0 in the identity property. So here we have found it as a 0. Okay, now write the equation. Test for each element of the set 0, 1, 2, 3, 4, 5, 6, 7 and find out the element on which if you perform the addition modulo 8 operation and result is 0. So for 0 it is identity, so its inverse is always a 0. For 1 on performing operation with 7, which operation? Addition modulo 8 gives you 0. 2 plus 6 8 mod 8 0. 3 plus 5 8 mod 8 is 0. 4 plus 4 8 mod 8 is 0. 5 plus 3 8 mod 8 is 0. So similarly it is satisfies inverse property. Hence this is a group. Okay, now what is the definition of abelian group? Now only one property we have to check, and which is that property? That property is a commutative property. So we have checked all the properties till now. Last property we will check. Which property? Commutative. And what commutative says? If A star B is equals to B star A. Or here we will write our operator is plus 8 A plus 8 B equals to B plus 8 A. Now let us take any examples. Let us say A equals to 0, B equals to 7. Okay, so 0 plus 8, 7 is equals to 7 plus 8, 0. Okay, so 0 plus 8, 7 is 7, which is equals to 7 plus 8, 0 is 7. 7 plus 0 is 0, 7 mod 8 is 7. 0 plus 7 is 7, 7 mod 8 is 7. So it gives you left hand side and right hand side as the same. So this is commutative. Set is commutative. Commutative for operator addition modulo 8. Therefore, set for addition modulo 8, set G for addition modulo 8 is a abelian group. Why it is abelian group? Because it is satisfying all the properties: closure, first closure, associative, identity, inverse, and commutative properties. So that's why this set is called as the abelian group. We have asked the question whether it is abelian group or not. So we have tested first closure property, then we have tested associative property. So it is satisfying both these properties. Then we have tested identity property. It is satisfying the identity property also. Then it is satisfying the inverse property. And finally, it is satisfying the commutative property. So as it is satisfying all the properties, it is called as the abelian group. So that's why we are saying that it is a abelian group. So thank you. Next lecture we will study more examples based on this topic.